my first derivative is 2x log x plus x. Yeah. You can see the way I've done product rule. There's my v u dash and my u v dash. I know, by the way, I would just comment. I say it like that. I'm conscious of the fact that some people do it in the reverse order, which is fine because it's addition. The reason I do it in this order is, well, can anyone tell me why I do it in this order? It's because it helps me get the quotient rule right where the order does matter, whereas here you can put them anywhere you like. Quotient rule's different. So let's move on to which didn't appear in this quiz. Let's move on to the chain rule, 1 plus sine x to the 5. So you can see there's my outside derivative. Yep. And there's my inside derivative. Are you happy with that? Yep, looking good. Well, no. I just found it a little bit awkward to write it like that. So coefficient out the front, 4x cubed and 1 minus cos x. Again, you can see my v u dash and my u v dash. You got a double negative happening there because cos x differentiates into minus sine x, and there's already a negative there. So that's why I just have positive sine x. Did you have to factorize? Again, not really. We talked about this last quiz, right? But it just looked messy to me, so I just mucked about with it a little bit. And here, last one in just the straight derivatives, you can see what I've done. Here's my, what have I done first? There's my outside derivative. Yeah, you see that? So I've brought the power out the front, and then I've reduced the power by 1. And then here is my inside derivative, which is chain rule, but it's simple chain rule. Yeah? Are you happy with that? I suppose I could have, if I wanted to, said negative sine x. No, hold on. Yeah, that would have been fine. But being that you just asked for the derivative, right? You just asked for the derivative. This is fine. Yeah. So say it again.
Oh, Brendan, you were so close.
I did the double single.
Sorry, I'm a bit confused. What do you mean? You got this? Yeah, that's fine. Yeah, it's okay. Which, by the way, will come up for us in the extension 2 exercise in a minute. Let's just go down to this simple log. This is what you get. So you can see, again, I know you don't have to do this. You may well be able to do that in your head. But this is just a strategy I've taken for myself to minimize silly errors. I've learnt not to trust putting things in my head. So that's why the half comes out the front. And there you go. Okay. Any questions on the first column? Looking good? Let's move over. They hand you the substitution we've established. Because I rubbed it out. Because if in fact, where is it? It's somewhere in... There it is. Yeah, I just rubbed him out. Anyway, as I've mentioned in an extension 1 context, you'll more likely than not be told the substitution. So therefore, all you have to do is do the necessary differentiation so you can change the variable that you're integrating with respect to. And then this should come out. What do you guys think? You happy with that?
So the C constant doesn't need to be inside the bracket or outside.
This constant, should it be inside or outside? Answer is it doesn't matter, because if you have a constant or a constant divided by a third, it's still a constant. However, I've left it inside the brackets, just personally, because number 1, I had no reason to take it out. Number 2, if I take it out, unless it's 0, it's a different constant, right? So if I had written, for example, oh, I agree, but at this point here, I need the constant of integration, and I haven't done my substitution. So if I had written this, well, like I said, unless it's 0, these two numbers can't possibly be the same, and so I really should say something like C1, C2, and like, anybody got time for that? So therefore I just left it inside. Okay. All right. Let's move on to, now you see why I gave you the reference sheet. So this question, did I do it wrong? Did I calculate? That's okay. Yeah. Degrees mode. Should have known. Okay. So I got. We agree. If you're in degrees mode, now can I just ask? Shh. You're 12. Legit question here. If you're in degrees mode, what answer did you get?
0.98.
Okay, 0.9 whatever. that should tell you, whoa, I've gone way off. Like, you guys remember how quickly Newton's method went, right? And they're already telling you, hey, it should be close to this, right? Newton's method makes mincemeat of an approximation task, right? I think I said before, when I first introduced Newton's method, that because of the way it works, if you use it in the right context and you avoid all the traps that we saw before, if you use it right, you basically double the number of decimal places of accuracy you get with every successive application. That means if you had 1, then you'll get 2. If you have 4, you get 8. It's just crazy. That's what calculus does for you, right? So that's why I knew I was on the right track, because I got an answer that was crazy close. Okay. Take pity on people like me who had to memorize Newton's method. Okay, last one, the volume. I'm not bitter at all. Here's the volume. Now, just for what it's worth, is this what you got? That's what I got? Yeah, okay. So let's just rewind. Shh. I always start this way. It's been a little while since you've done a volume. I like to put the pi inside because, again, it helps me to remember there's a pi there. It's so easy to forget. And what is this? What is this thing? Where does it come from? It's a formula. It's that infinitesimally thin cylinder, which has a volume of pi r squared h. Right? Do you remember that? So that's a mechanism for me. And then I just do the straight substitution with my boundaries and my function. Okay? So it's a straightforward substitution. Mark it and hand it back to your friend.